Okay, now we are on bond polarity. So polarity is, it's going to ask you on some of the questions on your homework whether it's considered to be covalent, polar covalent, or ionic. And it's all based on this electronegativity word. And this information right here is going to be needed in order to do that homework. So if it's 1.7 or greater, then it's considered to be ionic. If it's 0.5 to 1.7, then it's going to be polar covalent. So see how this says 0.5 to 1.7? So that's basically like saying 0.5 to 1.6 is polar covalent. And then anything that's less than 0.5 is just covalent. Okay, so what am I talking about at all? We'll see how this, I want you to see this shape right here. See how it's kind of like bigger on one side and smaller on one side? That means that there is an atom in this situation that is hoarding most of the electrons. So that would be a case like hydrogen, because it has one outer electron, and say chlorine, because chlorine has 7 outer electrons. So that one right there went with chlorine. Well, when they share, they're both being fulfilled. Hydrogen has 2 like helium, and chlorine has 8 like it's supposed to. But look how many electrons are around chlorine. So chlorine is sort of hoarding all of the electrons. And when it does that, it sort of makes hydrogen almost positive. This is sort of a funny looking symbol. It's not an 8. It's sort of a funny looking symbol for partial. And that's partially positive is the hydrogen, and the chlorine is partially negative. So what ends up happening is they almost are like an ionic bond, because I remember ionic bonds are like pluses and negatives. They're magnetic. Polar covalent is sort of like leaning towards that, but they're still considered to be sharing. So let me show you on this next one here. So this is also going to be needed for your homework. This is an electronegativity table, and it's going to tell you the electronegativity values. So if we do hydrogen and chlorine again, so hydrogen is 2.1 and chlorine is 3.0. Okay, so hydrogen is 2.1 and chlorine is 3.0. Oops, sorry. And this wants you to do the electronegativity difference. That's what it's going to say on the homework. So what you do is you take 3.0 minus 2.1, which is 0.9, right? And if you go back to this previous one, this said if it was 0.5 to 1.7, then it was considered to be polar covalent. So that tells you that the electronegativity for hydrogen and chlorine is polar covalent. Okay, now it might also have like, what's the electronegativity of, say, I don't know, oxygen and oxygen? Well, oxygen's 3.5 and oxygen's 3.5, so you end up with an electronegativity of 0. Well, 0.5 or less is covalent. So whenever you have them just sort of basically sharing and they're pretty much equal, then they're considered to be covalent, just regular covalent. And then if I did one that was like, say, let's do lithium, which is 1.0, and chlorine, which is 3.0. So if I do 3.0 minus 1.0, then I get a total of 2. Well, if you go back over to this slide, it says 1.7 or greater is considered to be ionic. Well, 2 is 1.7 or greater. So lithium and chlorine is an ionic compound. Okay, kind of broken up, sort of like this. I don't know if that made it better or not, but anyway, that's how you would do electronegativity. And then this is just showing like composition of compounds and how you can we'll get into in chapter 10, I believe, how you can kind of figure out the basically the percentage of elements that are in different compounds. But this gets us into how we're supposed to name compounds. And naming compounds is kind of a task. So, and this is basically what your lab next week is going to be. It's going to be a worksheet, kind of like that extra credit thing that I did. But you're going to have to fill it out and figure out what the names of the compounds are going to be. And basically, we know things as common names like baking soda and washing soda instead of, sodium bicarbonate, which is its actual chemical name. So we have to figure out how it gets the actual chemical name, okay? And most of the time, a common rule, that's this one right here, is that both ionic and covalent are going to end in "ide." Now, that's not always true. It depends on if you're doing just two elements or if you're doing, multiple elements. If you're doing things that has more than two, then it's possible that it's going to end in like "ite" or "ate." So I'll get into that soon enough. So for ionic compound names, I'll probably have to stop this video soon, but for ionic compound names, what you do is first you're going to name the metal, which is the positive ion. So for instance, if you were talking about lithium, something like lithium chloride, you would name lithium first, okay? And sometimes your suffix, which means that second element, so we have lithium chloride, okay, that was the common rule that they ended in "ide." But sometimes they can end in things like "ic" and "us." "Ic" is usually for higher of two and "us" is for lower. You don't really have to know like which circumstance to use that. You basically will just have to be able to read it off of a table, and I'll show you that in a minute. So there's two rules for ionic compounds. First, you're going to write the symbol for the positive ion first. So calcium's ion is +2, and then you're going to follow it by the negative symbol. Okay, and this is where that crossover technique, that's what they're calling it, is the crossover technique comes in, where I said, okay, take this 2 and pull it down, and then take this 1 and pull it down. So you end up with CaCl2. Okay, so hopefully you guys are understanding what I'm saying when I do that. I can't ask if there's any questions. So this is where if you do have a question, you need to message me about this at some point this week. Okay? And so see how there's just 2 elements? So whenever there's just 2 elements in an ionic compound, you list the metal ion first. This is sort of the formula way of writing it, and this is the word way of writing it, words, I guess. So you list the metal first, calcium, and then if you look, it's not chloride on the periodic table, it's chlorine. But whenever you're doing it as a compound, it ends up having that ending "ide." Okay, so calcium chloride. But this is how you would have to write it as a compound, as a formula. And you will have to do that on basically a worksheet, which will be your lab, essentially. That will be next week, though. Okay, I'm going to stop the video.